Welcome to an algebra tutorial video working our way through direct variation. In this particular video, we're going to talk about if I'm given a graph, how do we find the direct variation equation from the graph? In particular, how do we find k, our constant of variation? All right, so let's take a look at the graph I've got here and start breaking things down. It looks like a nice straight line. It's going through the point 0, 0, which is good. So that means it's direct variation. And it's so straight line 0, 0 is direct variation. So we're confirming that. Now I'm also given some information about some points. Looks like I got negative 10 and 2. There's another point, negative 5, 1. And two other points, the coordinates are there. And I'm remembering that the horizontal axis is telling me the value of x for each point. And the vertical axis is telling me the value for y for each point. So I'm going to go ahead and label that this negative 10 is an x value. That 2 is a y value. This negative 5 is x, that 1 is a y. This 5 is an x, that negative 1 is a y. And that 10 is an x, that negative 2 is a y. Okay, so how do I find k and begin to write an equation that fits what I'm being shown in the graph? Well, what I would recommend is taking these points and actually substituting x and y in for the equations and then solving for what's x. So I'm going to write 4 different equations, one for each point. We can kind of see how that happens. So the first one, if I make x negative 10, y should be 2. So let's see. So if y is 2 equals, I'm going to leave my value for k as purple, times, and x is negative 10. All right, let's take a look at the second one. If x is negative 5, y is 1. So let's do y is 1 equals, I'm still solving for k, but my value for x is negative 5. All right, let's look at the third point. If x is 5, y is negative 1. So let's put negative 1 in for y. I'm still going to solve for k. I don't know what k is, but I know my x value in that case was 5. So 5 times k equals negative 1. And we got one more point to solve. It's 10, negative 2. If x is 10 times a sum value k is equal to negative 2 for y. All right, so we got 4 different equations. Each one of these I can use to solve for what k is. If I use some simple algebra. So to solve for k, I just need to divide both sides by x. So let's divide both sides by negative 10. And k equals, and looks like in that first one, k equals 2 over negative 10. But I can reduce that down. 2 over 10 is 1 over 5. And if it's just all negative, it's just negative 1/5. Let's see if I get the same thing for all the other ones. If I divide this one by negative 5 on both sides, we get 1 over negative 5, or negative 1/5. If I divide this one by positive 5, k is negative 1/5. And lastly, if I divide both sides by 10, negative 2/10 also reduces down to negative 1/5. So there we go. Our constant has shown itself to be constant. I can take any point, substitute the values of that point into my direct variation equation, and solve for what my constant of variation k should be. So I can conclude that this line, the one that's graphed here with these points showing, has to be the equation y equals negative 1/5, that's my constant, we just solved for that, times x. All right, hopefully that's helpful. A helpful example of if I'm given a graph, how do I find the constant? How do I make an equation from the graph?